Welcome back to 10 Applied Math. Today we're going to continue with solving linear systems, but today we're going to investigate a different method called elimination, and we'll discuss that in just a minute. The reason why we look at the method of elimination is because there are limitations to solving linear systems by graphing. There's the obvious ones where maybe you don't have a piece of graph paper, but there's also some other practical reasons. For example, here are two lines. They're both in y equals mx plus b. So we could very quickly graph them. So this one is graph A, and so it has a y-intercept of 8. And that's this line here. And this one is line B. It has a y-intercept of -3 and a slope of -2/1. So you would count down 2 and over 1. So there's our two lines A and B. And we discussed last day that a solution to a linear system is in fact the common point shared between both lines. So I was using the terminology point of intersection. So where do these 2 points meet? Well, the two lines intersect right here. And so we would identify the coordinates x and y at the point of intersection, and that would be called our solution. But if you look closely, we've got a bit of an issue here. And it has to do with the fact that our solution involves decimals and fractions. We are not getting an integer value, meaning a whole number for either x or y. And so in this case, we can only estimate the solution. We know that the x value would be between -2 and -3, and the y value would be between 2 and 3 when you're looking at the y-axis there. So it's just an approximation. So we want to then choose an algebraic method that will allow us to come up with the exact answer. Because we're practicing mathematics here, we want exact answers. And so the method of elimination will allow us to get an exact answer, whether it's a decimal or a fraction or an integer. We're going to get the exact value for x and the exact value for y. Now today, the method of elimination we're going to be using involves addition. So we're going to break this down into two parts. Today we're going to discuss addition, and next lesson we will discuss subtraction, and then in our third lesson on elimination we will discuss the differences between when you add and when you subtract. So today we're always going to be adding our equations. So going back to the example up above, y equals 2x plus 8 was our first line A, and our second one was y equals -2x minus 3. Now what we're going to do is we are going to add these equations together, and we're going to create a single equation. So right now, the way it's written, if we draw a line underneath, all our y terms are lined up, and our x terms and our constant terms. And that makes it easy for us to then add. So what we're going to do is we are going to add. And when we're adding, we have to follow the idea of collecting like terms. So 1y plus another y gives us 2y's. Now 2x plus -2x, because they're opposites, we end up with 0x. And then we work with the constants. +8 plus -3 becomes 8, subtract 3, which gives us 5. So when we do that, we are collecting like terms. Now what's interesting is this, the 0x. 0 times x, or 0 times any number, is equal to 0. So we clean that up and we write 2y is equal to 5. And what's happened is the x terms have been eliminated. They've disappeared. We no longer have any x terms. We are left with an equation involving just one variable, in this case y, and then we can proceed to isolate for y. So I divide both sides by 2, and I find that y is equal to 5/2. So now we know that y equals 5/2 is part of the solution. Now we know that a solution has an x part and a y part because it's part of an ordered pair. So this is the y component of our ordered pair, we need to find the corresponding x value that matches up. Now, because it's a solution and it belongs to both lines, we are going to take y equals 5 over 2, and you're going to substitute it into either equation to solve for y. Now, I've chosen to use equation A. So equation A is y equals 2x plus 8. And I have replaced the y with 5 over 2. And when I do that, I'm now left with an equation in one variable where I'm going to proceed to solve for x. Now, with the introduction of y is 5 over 2, we've introduced some fractions, and we have discussed earlier on back in March how we solve equations with fractions. We use the concept of the magic number to eliminate all the fractions. So the number in the denominator is 2, so we were calling that the magic number. Now, whatever you do to the left side, you have to perform the same mathematical operation to the right-hand side of the equation to keep it balanced. So we're going to multiply both sides of the equation by 2, and then you're going to proceed to simplify. So we have 2 times 5 is 10, divided by 2 reduces to 5. And on the right-hand side, we have to apply the distributive property. So 2 times 2x gives 4x, and 2 times 8 is 16. And then we're going to proceed to isolate the x term. So I'm transposing the positive 16 to the other side to get negative 16, clean it up, and then we divide both sides by 4 to find that x equals negative 11 over 4. So we have now found the x value for our solution. So we pull it all together and we say the x value is equal to negative 11 over 4, and the y value is equal to 5 over 2. That should be the common point. We should also go through the process of doing a formal left side, right side check to verify that this is indeed a point on both lines. Now, the calculations are going to be a little bit messy because we have fractions, but nevertheless, we need to go through the process. So let's do a quick check. So for the equation A, the left side is equal to y, which is going to equal 5 over 2. The right side will equal 2x plus 8. Our x value is negative 11 over 4. And we're going to reduce the 2 in the numerator with the 2 in the denominator. So we're going to get negative 11 over 2. Now, I'm going to be adding that to an 8, but because I have a fraction, I know that I need a common denominator. So the 8 will become 16 over 2, and then you keep the denominator the same and add the numbers in the numerator. So negative 11 plus 16 is equal to 5. So the left side equals the right side for the first equation. And then we'll try the same thing in equation B. The left side is equal to y, which is 5 over 2. And the right side will equal negative 2x minus 3. We replace the x with negative 11 over 4. And again, the negative 2 and the 4, that will give us negative 1 times negative 11, which gives us positive 11 over 2 minus 3. And I know that this needs to be a fraction, so I'm going to convert that to an equivalent fraction. So now we're going to subtract the numerators. 11 take away 6 is 5 over 2. So there we go. Left side is equal to right side in both equation A and equation B. And so now I'm confident that we do in fact have the correct solution. So let's look at some additional examples. So in all these examples, we are going to use addition. We're going to solve the following systems of equations by adding the equations. So I am going to draw a line underneath, and you'll notice that my x terms, my y terms, and my constants are all lined up on top of each other. Everything's nicely organized. So now 2x plus 5x sorry, 2x plus 3x is equal to 5x. Positive 1 plus negative 1 gives us 0y, and 9 plus 16 is equal to 25. So now we have 5x is equal to 25. We divide both sides by 5 to get x is equal to 5. So now we know that the x value for our solution is equal to 5. To find the y counterpart, we substitute this value into either equation. So I'm going to sub x equals 5 into, I'm going to pick A. So it'll be 2, replace the x with 5, plus y is equal to 9. And when we do that, we're now finding the y partner. So we'll have 10 plus y is equal to 9. Y equals 9 minus 10. Y equals negative 1. And then we put that all together. Our solution, xy, is equal to 5 and negative 1. Now, we ended up with some integer values, so this means our check will be a little bit easier, but we should practice the check, and I can't stress enough the format for the check. You need to work with each equation separately. So for equation A, the left side will be 2 bracket, replace the x with 5, plus the y value, which is replaced with negative 1, which becomes 10 plus negative 1, which is 10, subtract 1, which is equal to 9. And the right side was equal to 9. So left side equals right side. That means 5, negative 1 is indeed a point on line A. Then we also have to check it in equation B. So the left side is equal to 3, replace the x value with a 5, minus y, which is negative 1. This becomes 15 plus 1, which is equal to 16. And the right-hand side was 16. So the left side is equal to the right side. Therefore, we have the correct solution. So what this means is that you can actually verify your work. As you go along, you can do formal left side, right side checks to verify that you have the correct solution. Let's look at 2 other examples. Okay, and see if you can do these on your own. So we have 8x plus y equals 21, 11x minus y equals 17. We are going to add these two. So that'll be 19x plus 0y equals 38. 19x equals 38. So x will be 38 over 19. So x is equal to 2. To find the y counterpart, you can substitute into either A or B. I'm going to substitute x equals 2 into equation A. I'm going to call this one A and this one B. So that'll be 8 bracket 2 plus y is equal to 21. Clean this up. Y will equal 21 minus 16. So y is equal to 4. Therefore, our solution is the point 2, 4. And you then verify again that you have the correct solution by going through the formal left side, right side check. And one more example, example 3. We are going to add A and B, equation A and equation B. Everything's set up that the x terms are lined up on top of each other as well as the y terms and the constants. So this will give us 0x plus 4y is equal to 12. 4y will equal to 12. So y will equal 12 over 4, or divided by 4, which is 3. So in this case, we actually eliminated the x's and we were left with y, and now we're going to use y to find its counterpart x, okay? So sometimes you're eliminating x and other times you might be eliminating y, but the procedure stays the same. So we are going to sub y equals 3 into one of the equations. I just keep picking a because I see all positive terms. I think I'll make it a little bit easier. So 4x plus 3 bracket, replace the y with 3 equals 7. 4x plus 9 is equal to 7. We're going to transpose the positive 9 to the opposite side. So 4x will equal negative 2. Divide both sides by 4. So x is negative 2 over 4, which reduces to negative 1/2. And therefore, our solution to this system is written as an ordered pair, xy equals negative 1/2 and positive 3. We should go through the process of completing formal checks. But you're going to get lots of practice with that in the homework.